Hey there, everybody. Welcome to another episode of Beer with the Boss, that podcast where a guy and his boss have a beer, talk about technology and whatever is trending out there. Don't forget to subscribe to our channel, like this episode, and activate notifications so you will know whenever we have a new episode live. My name is Rodrigo Matos. I work at WebBeta, and today here with me, as usual, is my boss, Joe Zamboni. Hey there, Joe. How's it going?
Hey, Rodrigo, thank you for introducing us. Thank you, guys, for joining our podcast today. I hope you saw that we have more places now. And today, again, I will be short here. I have two problems. I want to know the beer that you're drinking, and we have another guy here on our podcast today. Who is this guy?
Yeah, I'm drinking actually nothing special today. Good old Stella, just a Pilsner, but still doing the job. And yeah, we do have somebody different with us today here. Would you like to introduce him, Joe?
So today we have here with us is Moustafa. He is our friend, worked with me in some projects in the past, and today he works at a company called Dito, and I don't know which pronunciation is correct. But you didn't ask me, but I'm drinking a Paulaner, so it's Oktoberfest. So October, first podcast of October, I think.
There you go.
And Moustafa is here today to talk with us about a brand new old technology that is with the old name called Rust, but it's kind of new, roughly 2009, 2010, something like that, invented by the guys from Mozilla. But recently, there's been a lot of people talking about. So I tried to find between my friends the best one, the one who knows more about everything, and I brought him today here.
No pressure. Wow, that's a lot to pile on there, Joel. Appreciate that. Yeah, I'm drinking a Barbican, not a beer, so just like it's a malt beverage. It's close, but not all the way there. Non-alcoholic.
Yeah, we accept no alcoholic. Yeah, we're fine.
So I work for Ditto right now, and in the past I've sort of worked with Joel. We've built some things around Kubernetes, some controllers and things like that in the past, and kind of what I do at Ditto right now is like I'm a backend engineer. I work on all the stuff that's behind the scenes, you can call it. And Ditto kind of makes a platform for like peer-to-peer networking and database layer. You can build it into your applications, and we have a cloud service associated with it. All of this to say it's all built in Rust, and so a lot of the stack that we work with at Ditto is in Rust. And so I've since joining the company kind of like learned Rust. I used it a little bit before, but not very deep. And I wouldn't call myself a Rust expert, so I just want to like disclaimer before diving in. But I've used it now for a couple of years, and I feel like I understand sort of like generally what the language is good for, the benefits and drawbacks a little bit, and we can talk a little bit about that.
Yeah, Rust, like it's being like all over the place now. It's part of the Linux kernel, and there's a lot of projects coming out. Like I saw one terminal developed to macOS. I think it was crazy. It was like it's almost like you have an editor in the terminal. It was like you can edit and do multi-command line editing. It was like it's crazy. So not only the language seems to be more stable, right, or more secure in a way, right? Because the way that you handle memory and all those things. And well, I think you can explain better to us than myself here. But I think, Rodrigo, you have some questions to him, right?
Yeah, sure. Just to start, a simple question for someone who is not a technical person, maybe what is Rust in a nutshell? Would you explain that to us?
Sure. Yeah. So actually, I pulled up the Rust lang.org website to kind of see what the new tagline says, because it used to be that said like Rust is a systems programming language, and it'd be a little bit more focused on the systems programming space, but they changed it, I think, or more recently, or at least since I've last looked at this landing page. But this is now like a language empowering everyone to build reliable and efficient software. And I think that's actually a very, very good description, because you get a lot of um, cool benefits with Rust that make it so that you deal with problems that will eventually come up in the runtime much earlier in the life cycle of the product and whatever you're building. So it makes it easier to build safe things, right? Like ultimately, you get a lot of things like safe concurrency. So that's what makes it obviously very good for systems level programming, right? Systems level programming, it needs to work well, it needs to be performant, right? It needs to be safe, because that's where majority of security vulnerabilities and the in probably ever are from, like, doing the wrong things with memory and people taking advantage of buffer overflows and all kinds of things like that, right? Where essentially it's unintended behavior that can be taken advantage of, right? And Rust doesn't really let you do that, and that's sort of the big thing about it. Um, so yeah, I mean, it's a great language, I think, to be honest. Like, if people, this may be a little bit controversial, but like, I'm hoping that it can supplant C++ as a systems programming language just generally. But it can also be used to write things like what I personally work on very frequently, sort of the cloud native level, Kubernetes controllers, things like that. So it's a powerful language. You can pick sort of where in the stack you want to attack. You want to go very low level, you can go high level. There's quite a bit there that you can use it for.
The Rust is I think, yeah, the main thing I think was who was talking about this, the Linus Torvalds. He was talking that was supposed to be teaching the developer something, was a bad word in like always Linus. I don't remember his comment. It was like you enforce some things to happen in a certain way that you can't escape, right? And the nice thing is it's a language without garbage collector.
Mm-hmm.
Right?
Yeah, exactly. You get that consistent performance, right? Whenever you're writing something, it's going to take that amount of time to do its piece of work pretty consistently, right? You don't have any kind of like, oh, the garbage collector decided to start up and collect garbage. Now you got a spike in your performance profile for your application, or you're trying to figure out why this keeps happening, or it's doing things in inconvenient times. You don't have that. You got zero cost abstractions, and the borrow checker helps you to essentially, like, the compiler and the borrow checker help you to write code in such a way that it's safe, but also that it's very efficient. So it will decide, okay, you're done with this piece, I'm going to deallocate it from memory, right? It's never going to be referenced again. And not in a way that, like, in some interpreted languages like JavaScript or Python, they're actually actively sort of determining what should be in scope and what should be garbage collected. But as it interprets the program. But with Rust, it's at compile time. Now that does lead you to some, I would say, let's say, disadvantages for the development workflow, because obviously the compiler has to do a lot of work, right? It has to do a lot of work. It's very nice with the shipped final product, because the shipped final product is going to work, and it's going to work well, and it's going to be performant, and it's going to be safe, and you're not likely to have a lot of bugs if you've tested well and done some, idiomatic Rust. But it is a bit frustrating in the beginning, because oftentimes I think we learn bad habits, in like as we write programs, we decide, error handling, we can deal with that later, or what happens if this corner case is going to happen? Oh, we don't really care about that. We move on. But Rust kind of forces you to say, deal with these bugs first. You can't just write them in very easily, at least. So that's good and bad.
I can also make a question specifically for a language. Why would we select like Rust instead of Go? Like, because like we internally we just start like we decided we're gonna use Go for everything. So instead of Python and other languages that you use. So why would we change our mind and no, let's do Rust instead of Go?
I mean, this is ultimately, like, I'm not going to bash Go. I've used Go in the past. It's not a direct comparison. But I think it's easier to write safer code in Rust, and the bugs sort of come out up front as you're writing. As you're writing, the compiler is telling you like, hey, there's a bug here. Hey, there's a potential bug here. Hey, there's a potential bug here. Now that can be very frustrating as you're trying to just make something and ship it, right? And so that's sort of the double-edged sword, I think, with that one, right? Just like there's a benefit, and that at the same time that benefit can be sort of a negative. You can think of it, right? Because if you're trying to ship something and just like see what sticks type of thing, or you don't really care about how well it works, yeah, Rust is not really good for that. It's a little bit forces you to think through certain things. Now there are ways to like write Rust in such a way that you can just avoid handling a particular type of error, or just panic if this thing happens that you don't think is that big of a deal. So you can get past those things, right? But ultimately, it's very explicit, right? So there are things like in Go, error handling is
it's not
great. Yeah, exactly. Let's just say that, right? So
it's not.
Whereas with Rust, you don't sort of have like this just like Java model of like exceptions, and you don't have the Go approach of just return the tuple and one of them is an error and is error and all this stuff. With Rust, you actually have like a couple of different types that are very useful. Okay, and they're kind of built into the language, right? The first one is the result type. Okay, so every thing that could fail, okay, you can return what's called a result type, and the result type is essentially an enum, okay, of an okay and an error. So you can return the okay state, right, and say this is okay, and here's my data that I needed to return from this function, and then an error, and it's an enum, let's say, of all the different types of errors, and you have to handle all those errors, right? So you have a concept in Rust or I guess a syntax called a match, right? It's very similar to like a switch statement, maybe, but the compiler forces you to be exhaustive. So you have to handle each of the types of matches that could come out from that, right? So that's one. It's very beneficial. It makes you handle all the errors as you get them back. And then the second one is the optional type, right? Because oftentimes, null. There's no such thing as a null in Rust. You have a none, right? Which is it's actually an enum also, right? You have this is option type. Option is has a sum with the data with the actual thing that you're wrapping with the optional, right? And then you have a none, which is kind of like a null, but you have to explicitly handle it. It doesn't. You can't treat it like it is the thing. Or you have to unwrap it to actually get the actual thing. So if you unwrap it, you have to kind of handle the none case. So it makes it so you don't really get all these like nil pointers. What happened when you don't get some data back? So to me, it's very, very good for writing safe concurrent code, right? Which is a bit harder to do in Go, I think. Go doesn't exactly enforce safe concurrency, right? So you can share data structures between threads, and if you're doing things with channels and things like that. So, but with Rust, it's like you're not allowed to share data in an unsafe way unless you put an unsafe block and you say, I know what I'm doing here, okay? And you generally, for the higher level programming needs, okay, that I typically work with, you don't need to be using unsafe. In fact, unsafe is where you can get yourself in trouble. If you're writing very low level things where you know this thing can be provably safe, you have to tell the compiler, hey, this is unsafe code, but it actually is safe because I'm writing here. This is the rules for this code, right? Then you can kind of get away with things. But for the most part, like most people in most applications don't need to write unsafe code. And so you can write very, very safe concurrent code, which is very performant too. So you don't sacrifice too much, to be honest with you. You just sacrifice a little bit of time up front with the compiler.
But then after is later.
Exactly.
I think we got the last question.
Are you convinced, Joe?
Yeah, I don't know. I was like, I want to ship things. I want to ship.
That was a very good.
Now, what I heard is that Go is kind of even their site is like, we are the DevOps language, right? Like there's many tools, like the whole DevOps word is basically written in Go, right? It's like Kubernetes, Docker, Terraform, everything is written in Go. So I guess people say the threading model in Go is easier than Rust, although there's the insecurity, but it seems reasonable because there's so many tools in the area.
I think with Go, like they're doing a bit of a more green thread approach, right, for currency, and you have the runtime itself. Whereas with Rust, because it can be used for all these different things, like you have to pick a runtime. You can use async await, and you can write concurrent code that's going to do something very similar to what Go does. But you have to actually explicitly pick the runtime, and the runtimes might have sort of different properties that you're contending with. So there's a bit more getting started with. But like I think the reason maybe Go has been used so extensively in a lot of the DevOps and infrastructure world is probably just because of timing, to be honest, and who wrote it and what they were doing with it, right? Ultimately, I mean, the fact that Docker and Kubernetes and a lot of container runtimes are written in Go, to me, probably is happenstance. Now that I've used both, I think a lot of things would benefit um, from the properties that Rust has. Not everything, right? And obviously, like it's easier to get started with Go, I think for sure, right? There's no question. The ramp up time is not very long, but yeah.
And for those aiming to get started with Rust, what would you recommend?
The Rust book, like that you can get on their website, is quite good. There are quite a few sort of vloggers out there that will do like programming sessions where they kind of talk through how you might implement certain common data structures and algorithms in Rust and get you a little bit familiar with working with the language. And I think it just takes some time, right? Ultimately, like you have to spend some time doing things that you know how to do so you can understand how the compiler works with you.
Yeah. So the first guy that I saw writing Rust code online was a guy called the Primagen. The Primagen. And I kind of took like Rust start negative, like on my thing. It's like 0 to 10, like -10. Just joking. he does a lot of. He's a fun channel. He does coding in Twitch.
Yeah. So there's quite a few of these type of yeah.
Yeah. So he is like you have to watch him to understand what I mean. Like here, and I even like on YouTube I'm doing like the subscribe, and then there's a upper level that you do perks or something like that. I just because he's nuts, and I learned about him because of Vim. I'm a Vim user, so yeah. So, but I guess there's many guys now doing this code over the internet. It's kind of cool. I think is some things that we are.
Yeah, definitely. That's helped me to learn a lot. Just by sort of following along. Like you know how to implement this thing. Let's say simple data structure algorithms type things, right? So a linked list or whatever it might be. And then you could follow along. Like you know how to do this in one other language. You try it in there. If you're sort of just learning, like learning to program sort of as a complete beginner, I think it's going to be something that you can learn through the Rust book and stuff like that. It actually teaches you, I think, like if it's your first programming language, I would say it probably teaches you some very good habits that a lot of people don't learn in a lot of other languages. But it is frustrating probably in the very beginning to say, okay, I have to get this thing to compile. The hello world is very simple, is very, very easy. But anything sort of relatively sophisticated, we're trying to share some data or move some data around. You got to start thinking about, okay, references and mutability and things like that. But it because of the safety aspect that I kind of mentioned earlier, it sort of trains you to say, okay, I shouldn't have multiple things change this thing, because if multiple things are allowed to change this thing at the same time, I could get into indeterminate states, things like that. So these are, I think, generally good practices to kind of familiarize yourself with and avoid bugs.
Awesome.
Well,
so
thank you
do you
so
still
much,
have a beer?
Moustafa.
I don't have my beer.
Yeah, I'm out of beer as well. Well, thank you so much, Moustafa, for being here with us today. Really appreciate your insights. I'm sure that this is just the first time you're going to be here with us. Hope to see you again. And well, thank you so much, Joel, as well.
Thank you guys for having me.
Yeah, right. Thank you guys for joining us. I hope you see you again here. And we find us on Twitter at weareabear.com. And let us know what's the next subject. Thank you, guys.
Awesome. Thank you so much, guys. Thank you, Joel. Thank you, Moustafa. And for all of you listening to us, I'll see you next week. Bye.